Hello everyone, my name is Morteza Bashsiz. I am a Linux system engineer. At this series of videos, we are going to find out how to be a good Linux system engineer. So if you want to know, stay with me. Welcome to LSE episode 6. At this episode, I will talk about protocols. What are protocols, what kind of protocols we have, and also how the protocols are interacting with each other in different layers of networking. So let's start it. Okay, what we have here at this episode, we are here at this overview, and today we are going to talk about protocols. What is protocol? In a simple sentence, when two endpoints which they want to interact and communicate with each other over network. There are a bunch of standards for communication between two endpoints in different layers of networking called protocols. So, in a simple sentence, a protocol is a standard way for communication between two endpoints. There are different and several types of protocols in different layers of networking. For example, we have the protocols that are called application layer protocols. It does not mean that, okay, they are only at this layer of OSI model. Okay, when we are talking about application layer protocols like HTTP, FTP, and the others that you can see here, we are talking about the protocols that are defined and working at these three layers. So, an application layer protocol is a protocol that works in this layer and from TCP/IP and also these layers from OSI model like HTTP, FTP, SSH, SMTP, DNS, PTR, and SIP. And also there are other protocols in other layers of networking, like for transport layer, which is the same in OSI model and TCP/IP model. We have TCP and UDP, which are the most important protocols at this layer. And for network layer of OSI model or internet layer in TCP/IP model, we have IP, ICMP, and ARP, which are the main protocols here. Now we can understand that why IP is the abbreviation of Internet Protocol, because it is at this layer, the main protocol of internal layer in TCP/IP model. And for the other layers, layer 1 and 2 in OSI model and network interface layer of TCP/IP model, we have these protocols, for example, which are the low-level protocols in networking. Now I want to check what are these protocols and what's important to know about them, and also how they are working together in different layers of networking, and how, for example, how HTTP works over TCP and what is the relation between HTTP in application layer and TCP in transport layer, and how IP works here to making a connection between two endpoints, and what are these protocols in different layers of networking. Okay, with an example, imagine that we have two endpoints A and B that they want to communicate with each other over network. And for communication between these endpoints, we have two choices. We have two different roads. One road here and here. This road is called TCP and this road is called UDP. And over TCP connection on TCP road, we have a police officer here and also a police officer here, which they are responsible for controlling and checking something. So all the data which will be transported over TCP road should pass some checks at the beginning and at the end of the communication. But over UDP, we don't have these checks and this checklist, and we don't have any police officer at the beginning and at the end of the communication. And also we have different applications here which they want to use these roads for transportation, like HTTP, like FTP. For example, we have DNS, we have SIP or RTP. And HTTP uses TCP for transport, FTP uses TCP for transport, DNS, normal DNS by default is on UDP, SIP by default and usually is on UDP, and also RTP the same, uses UDP for transportation. And here we could say that we have a TCP communication which could be HTTP or FTP, just as an example, inside the communication. And the same for UDP. We could say that we have DNS, SIP or RTP. But don't worry about these protocols, that what are these? We will talk about them later. At the moment, at this episode, I want to use just examples to describe what is the relation between different protocols in different layers of networking. Now we can understand that what is the relation between application layer protocols and transport layer protocols. And in one simple sentence, application layer protocols will use transport layer protocols for transporting data between two endpoints. So in transport layer we have two main protocols, TCP and UDP. The main difference between these protocols is that TCP is connection-oriented protocol and UDP is not a connection-oriented protocol. And what does it mean? What does the meaning of connection-oriented? Imagine we have two endpoints and we want to transfer data from A to B, and between A and B we have several paths and roads to transfer the data. In TCP, before transferring data, a session between two endpoints must be established, and the data will be transferred over established session between two endpoints. And if session fails in somewhere between two endpoints, then the transferring data will be failed because the session is expired and failed and broken. Then TCP will try to establish a new session between two endpoints. And also after establishing the session, the data will be transferred over the new session between two endpoints. But who is responsible for checking these things here between two endpoints? The police officers that we mentioned in previous slide. Okay, and exactly these officers are working at this layer of operating system. So everything related to session is handling at this layer. And what about UDP? UDP is not same as TCP, it's not connection oriented. And how it works? Imagine we have the same endpoints and we want to transfer data from A to B in UDP. In a simple description, in UDP, A sends and hopes B will get the data. Until now, the main and important difference between TCP and UDP is that you can trust on TCP, but you cannot trust when you are using UDP. Because nothing checked here in UDP and you cannot make sure that your data received in the destination or not. And UDP works like this, that it sends the data and does not important that this receiver gets the data or not, just sending. Now I want to talk about the differences between TCP and UDP by a real example. Imagine we have telephony service or VoIP, that you have two persons that they want to talk with each other. While talking with your friend, the quality of the voice is not really matter, and it's not the most important thing here. You don't care that you hear your friend's voice in a very, very excellent quality or in medium and low quality. And the most important thing here is the latency of the voice. So latency is the first important thing here. And also at least you understand what he or she is talking about. And you are generating the voice, for example, with 1000 packets per second. And your friend is getting with 40 packets per second. And also your friend is understanding what you are talking about. So the quality is not important here, and you start to send with the high quality, and here the connection and the internet and the bandwidth is low, and then your friends get with lower quality, but it is okay. This was one of the use cases of the UDP. One another and important use cases of UDP is for DNS. All the DNS resolution queries and requests are handling over UDP. And the default port for DNS is UDP port 53. For example, you have a client that wants to resolve a record from DNS server. don't worry about what are these. I'm just trying to describe it with an example from real world. What is DNS? We will talk about it later in next episodes. But here in resolving DNS, the interaction between client and server is so easy and simple. Client sends a request, server responds to the client. So simple. And here is one of the use cases of the UDP. And client asks, okay, what is the IP for domain sudoer.ir, and client responds the IP for the DNS server responds the IP to the client. And now an example for TCP. Imagine that you want to download a video from a server. There is a video file on the server and you want to download it from the server. And you are going to download a single file with, for example, 3.5 GB of size. So here you have a single file with 3.5 GB, which contains a lot of bits together as a single file. What will happen if one of these bytes, for example, is broken? Okay. And if you lose a single byte from 3.5 GB of data, then all of your file will be corrupted and you cannot see and you cannot play the video in your video player. So it is important you get all of the file with the correct sequence and store it on your computer to be able to play it. So the session will be established between you and server, then the data will be transported over this established session till the download is finished. And this is how TCP works. And now we have talked about application layer protocols. I mean this part, and also talking about transport layer protocols. And what about the network or internet layer protocol? Now I want to describe what is important here. Now it's time to define the destination host and source host for sending and receiving the data. Here is where the IP, the protocol like IP or ARP will be used. I will talk about what is ARP at this episode because it is a protocol between layer 3 and 2. Now the data is ready and we want to send the data over network. So we need a DST IP, the destination IP address. For example, destination IP address is this. and source IP address is for example this. So we have a packet with SRC and DSD, which the IP and port at least are important here. Okay, we found out the IP and port and we want to send it. We need a physical address of the destination host. I mean, we need a MAC address. So we have another operation to translate between IP and MAC address. The operation of translation between IP and MAC address is with ARP protocol, Address Resolution Protocol. Imagine that ARP in a simple thing is a table with 2 columns that we write, for example, IPs here and the pair MACs here. So simple and so easy. And please pay attention, I'm not describing the ARP protocol or what is the packet and the others. At the moment, at this episode, I'm just talking about the concepts, what is protocol and the others. I'm just trying to explain them with real examples from real world. And then after we found out the MAC, we can send it over the physical layer. Until now, we generate data in application. We established a session over TCP and also not a session, but yeah, in transport layer we use UDP. I'm not writing it with TCP because we don't have a session in UDP. And after that we find out the IP and port to transferring the data, and finally translating IP to MAC address and sending over physical layer. So also we have some other protocols here that they are working with MAC addresses and the other data in these 2 layers. They are not respecting to IP. For example, imagine that MAC filtering or binding some ACLs on MAC addresses or ports of switches and the others are handling at these layers. And we are done for this episode. Thanks for watching me. Don't forget to support me with subscribe and like, and also share videos with your friends. See you in next episode. Bye.